All right, first question, Marston. I would really appreciate a good explanation for these types of questions. He actually submitted 3, but I'm going to go ahead and do this one. So a quadratic function has the roots of 1 plus square root of 3 and passes through the points 1, -9. Find the equation of the function. Okay, so a couple things we need to know. We need to know what do roots tell us about what our roots tell us about the equation of this. So let's just kind of go through a basic quadratic. If I had like x squared, let's do y. Y equals x squared, I don't know, minus a 5x plus 4. Well, we can rewrite that in the factored form of x minus 4 times a x minus 1. And if we wanted to find the roots or we want to find the zeros, we would replace y. I'll just call them the zeros, or let's just call them the roots. So there it is in factored form. So if we want to find the roots, we'll set y equal to 0. And then we can apply the zero product property and say 0 equals a x minus 4 and 0 equals a x minus 1. And therefore, oops, that's an equals. So then solving for x, we get x equals 4 and x equals 1. Those are the roots. So what's important about this is we are given the roots, and now what we want to do is we want to write the equation. So basically what we're going to do is we're going to go backwards, right? So we're used to going from an equation down to finding the roots. Now we're simply just going to go backwards. So I have the roots x equals 1 plus the square root of 3 and x equals 1 minus the square root of 3. So write this as x equals a 1 plus the square root of 3 and x equals 1 minus the square root of 3. Okay, so we had them set equal to x. Now, if we want to rewrite them set equal to 0, well, what I need to do then is subtract the 1, subtract the square root of 3. Subtract the 1, add the square root of 3. So let's go and do that. So x1 minus the square root of 3, that equals 0. And then here, x minus 1 plus the square root of 3 equals 0. And now you can see I can rewrite these in factored form set equal to y, which would be our function. You can set them equal to 0, but again, that we just did that for the zero product property. So I'll go from here to rewrite them in our factored form. So y equals a x minus 1 minus the square root of 3 times a x minus 1 plus the square root of 3. Okay, so there's one other thing, though, that comes into it. It says it has to pass through point 1 comma -9. So we have our zeros, so we know where the graph is going to cross the x-axis, right? Or we have our roots. We know where it's going to cross the x-axis. However, it has to go through a point 1, -9. So what can we do, right? We can't shift the graph left or right. We can't shift it up or down. Our zeros are fixed. Well, what we could do is we can stretch or compress the graph to be able to get that information. So what that means is we need to create another value, a. So a is going to be our stretch or compression. Now, again, we don't know what a is at this moment, right? But we do know that these coordinate points represent our x and our y. That's really, really important because I can plug in those values for x and y to be able to solve for a. But we're not there yet. We can't plug it in right now. Actually, no, let's go ahead and multiply. I didn't multiply this back out, but I was wondering, I'm like, could we actually just multiply it right now? It's in factored form. So why would we need to multiply this out? Let me actually work it out like that. Because we're just looking for a, right? So who cares? So this would be a 1 minus 1 minus a square root of 3. And this would be a 1 minus 1 plus a square root of 3. Well, 1 minus 1 is 0. So y is equal to a. So this is going to be a negative square root of 3. And this would be plus the square root of 3. Well, negative square root of 3 times the negative square root of 3 is, oh, shoot, that's supposed to be a 9. Sorry about that. Let's eliminate this. Yeah, so that's supposed to be a 9. So that's supposed to be a -1. Oh, -9. So therefore I have a -9 equals a times, this would be a -3, divide by -3, divide by -3, we get a +3 is equal to a. So now I can write my equation as y equals a 3 times a x. I still need to figure out the equation. So yeah, that's fine to do it that way. That's fine. But we still need to write the equation. So I still need to multiply these out. Okay. So let me show you how I would multiply these out. Let me get, there we go. Okay. All right. So I want to make sure I have enough room on there. So how could I multiply all of these out? Or how could I multiply these to get to my equation? So it's fine to plug it in right there. So if I was going to multiply this, x minus 1 minus a square root of 3 times a x minus 1 plus a square root of 3. You could multiply this using the box method, which I have no problem with. A lot of times I would just tell students to multiply this out. But let me give you a little bit of tip. This is what I would also do a lot with my pre-calculus students. I say, well, if you group the x minus 1, since those are exactly the same, what I want you to recognize is we can rewrite this as a minus b times an a plus b, right? The terms are exactly the same. As you can see, if you even put these in parentheses, your a and b are exactly the same for a little expression. The difference is one's a minus b times the other one's a minus b. So therefore, I can rewrite it as a difference of two squares, which would be a x minus 1 quantity squared minus a square root of 3 quantity squared. Now, hopefully you know how to expand a, there we go. Hopefully you know how to expand a quantity squared rather quickly. That's going to be x minus 1 times x minus 1. So that's going to give us a x squared minus a 2x plus 1. And then square root of 3 squared is going to be minus a 3. So therefore, this is a x squared minus 2x minus 2. So we have our equation, which is multiplied out, and we have our a. So my formula here is going to be y equals a 3, which is my a, times a x squared minus 2x minus 2. And now you can just distribute that to both sides, and you get y equals a 3x squared minus a 6x minus a 6.